Welcome back, everyone. And in this lesson here today, we are in shape optimization. This is going to be a pretty good project here today. We come back here, and this is project 8D, and you're taking this original design and you are going to add a force to it. All right. Let's say we're adding 1,000 newtons in this force going up in Y. And we're going to see, or actually in Z, we're going to see what areas are going to be stressed, what areas needs material, what areas have less stress, if no stress, that can be removed. And that's going to be the main thing because we're trying to optimize this part to where it's more efficient. Doesn't have to have as much material, and that way that we can 3D print it and we can use it in additive manufacturing. So this is what this part optimization is, and it's really cool in Fusion. So I've got the part up here, so let's go ahead and let's jump in. You've already had a little demonstration of it in a previous project in here in project 8. So again, we go here into design, or not design. Actually, I need to finish sketches in sketch mode. But we're going to come down here and we are going to do simulation again. And when we get in here, instead of doing static stress as we've done in the past, we're going to do shape optimization and create a study. So again, you still have to have the same components as you've had last time. You got to be able to constrain this thing down. And we've got these holes here that's going to be bolted. So I'm just going to catch the cylinder in them just like that. And hit OK. And now we're going to come up here to the top and we've got 1,000 newtons pulling on this thing in the Z direction. So again, we want to come over here and do loads, structural loads, grab this. I want to turn it to where I can see it's going exactly the way that I want it to go. And I want to change it. Now you can change by, moving things around, but I want 1,000 newtons, right? So I hit OK, and that has been applied. And the next thing that what kind of material? That might be pretty good to know. ABS plastic. So let's make sure that we have the correct material in here. Study materials. This has steel on it. So there's different ways that you can go in there and change the materials. Material properties, you could do it right here. It's going to tell you the materials of steel. But another way to make sure that you get it right is come back here, right click, and come down to your physical properties. And let's go ahead and change that to a plastic, ABS plastic, and dump it right in there on top of it and do a save. And that way we know that we're using the right materials. Then we'll go back to our simulation. Everything is still right there. Nothing has changed. That's great. Before I do the simulation, I want to do what's called preserve. And I don't want to mess with this hole any because there's going to be a pin through this, of course, and it's going to be pulling up. So I'm going to go back in, and you have shape optimization. You got preserve, okay? And I want to minimize that. And this is the area I want to preserve, is this whole area. And let's see, how much of a radius do I want to preserve it? Let's go in here and kind of piddle around with it. Let's say 10. No, I want to preserve that whole, just about that whole. That's too much. I'm not sure what that diameter was. I'd have to go back and take a look at it. I can do that. It's 15. 15 and then 6. So half of that would be 7.5, 12, 13.5. So it'll be 13.5 would be that diameter. 13.5, perfect. And what that does, that preserves, is when this thing starts stretching, it's not going to take this into account right here. It's just going to look at the other stress. It's going to show you where all the stresses are going to occur. This right here stays intact, okay? It doesn't do anything. It doesn't account for this far as the analysis. So I hit OK on that. And I want to do also, I want to make sure do a pre-check. And everything is there. So now I'm just going to results, or actually solve. And it just takes it a minute. And then solve. And it's going to take it just a little bit of time to do the solving on this. And we'll be able to take this information when this gets finished and be able to create the optimization, is actually cut the part down and thin it out to what we need. So we'll just give it just here a couple minutes and we'll have it. All right, it's done processing, and check this thing out. All right, we're seeing the stresses as this thing's being pulled, and of course there are going to be stresses around these holes where it's locked down. But you can actually too move these, and it'll kind of start showing you some stress points inside this thing. So there's a lot of stress right in here. You all see that? Keep that up there. So as we start looking at this thing, tons of stress all the way down through here. So that helps me to figure something out. I can actually open some, and I want to keep the same similar shape, but I could actually come in here and open up a little bit of a void in this thing. Okay, so the pressure's intense, it's pulling up, and the chance of it, and this thing's probably in pretty decent shape, but I can start, like I can come out here and I can put a fillet around this edge, fillets around these edges, fillets, but also I can open this right here up. I could probably come in here and cut most of this away here, because I wouldn't even need that unless there's a reason they need this on there, or we can put a big hole in it using our spline tool. So that's what I want to do. So I need this right here. So what I do is promote it. It's a tool called promote. So I hit finish sketch, and we can go back and look at the results anytime we want. But right over here in results tools, you can go promote and add mesh object to simulation model 1. Hit OK, and check this out. Y'all notice what we got here? We got the original with the stress mesh inside. Y'all see that? Pretty cool. You can actually change the visual style just a little bit so you can take a look at it, shade it. I can see it all really well. I mean, you can choose one of those. So this is where the major stresses are. So guess what I can do? I can go up here and create myself a new sketch around the face of this. And I've got all of this information to show exactly what I need to do, because undoubtedly they might need this design here with this angle on for some reason. But so I'm going to hit a spline, and I'm just going to go down through here because this doesn't have any stress on it. All right, that has a little bit of stress, so I'm going to come up and around it. Y'all see what I'm doing? And you guys can make this however you guys want to. This is your project. So I can finish the sketch out. I can extrude it and cut that through all the way. Y'all see how I did that? And also, let's go in there and let's add some more creations to it. Let's do this a fillet. I hit that. We'll say 5, or even more. We could say 10. Yeah, that looks pretty good. You guys just go in there and just add whatever you need. All right? And you can go around there and add whatever is needed to get this thing done. Catch this corner. 5. Yeah, we can probably go a little bit more. 8. That looks good. Okay. And, just make it your own. And thing of it is whenever you get the best design that you can get, you need to save it as an STL file. Now, it takes me back in to where, we went in and promoted and brought in our stresses into our original design so that we can make our cutouts, right? Well, from this point, we can go in and 3D print, save this mesh, go through here. Make sure to, in preview meshes, if you want to see that. But also do it with a high refinement. Turn off the send to 3D print utility, hit OK, and you've got it. So again, it's very, very important that you do when you're in there is to be in Simplify, to change that to an ST, to convert to an STL file. So again, get in there, folks, and get this done. You're going to take many, many pictures of this and put it on the submission form. Not only that, but you are also going to send me the STL link that's in your cloud drive. So if y'all have any questions, please let me know.